So here, since it's already in vertex form, there's no need to use the completing the square to get it into vertex form. So I'm going to just go and do this chart. On the midterm, you will be prompted to draw a chart in the axis of symmetry, so don't worry about remembering to do that. The vertex of this is opposite intuition inside the parentheses, so it's going to be 1, comma, -4. From here, I just have to choose a really easy number to work with. So I'll go ahead and choose 0. And if I plug 0 into here, I get -1 squared is 1 times 2 is 2, minus 4, 2 minus 4 is -2. And so -2 is going to appear yet again. It's going to be one space away, so it's going to be at 2. Alyssa, does that make sense? Okay, so now, go and draw this thing. My vertex is at 1, comma, -4. It's right here, and it's moving upwards. From here, my axis of symmetry does that, so it's going to be x equals 1, and that is my axis of symmetry. Right. Yael!
How do you know whether to put the 0 on the, like in the graph or chart thing? How do you know whether to put 0 on the top or the bottom?
It doesn't matter. I just put it. I like to put it numerically, going from top to bottom, like increasing as it goes down. It doesn't. It really doesn't matter though. Kate. Yes. Yes, I will. All right, that was number 55. That's gone. Number 67. Let's take a look at number 67 in the packet. Okay. David, this is your question, right? Okay. Can I do number 73 first? Okay. So let's take a look at number 73. It's x squared minus 13x plus 40 is less than 0. Okay, so from here we're going to factor this out first. It's a piece of cake. It's x minus 5 times x minus 8. So from here, because we're solving a quadratic inequality, we need to find critical numbers instead of solutions. So my critical numbers are 5 and 8, and that was received from this and this. Duh? Okay. So now what I do is I put this thing in a sign chart where 5 and 8 are my critical numbers. I partition it down, and then I put down my functions here, so x minus 5 times x minus 8. And now I choose a number that's lower than 5, so that's 0 or -1 billion. -1 billion is going to give me a negative number and a negative number. A number in between 5 and 8 is going to be, say, 6. 6 is going to give me positive here and negative here. How's it going? Thanks. And then beyond 8, it's going to be 1,000, so let's just go ahead and go 1,000, so positive, positive. So from here, my final intervals are going to be positive, negative, positive. So since my original equation here is less than 0, which interval am I interested in? Which interval is it going to be? Jake? The negative one, which is the one in the center. So here, I end up with my interval notation as 5, comma, 8, because it starts at 5 and ends at 8, and because I'm only less than, I do not include those values. I use double soft brackets. Does that make sense, David? Yeah. Okay, so let's take a look at yours, and let's see how yours is different and how yours is also the same. How yours is different is that it's already factored, which is a good thing. It's different because it has to, it's equal to also. So I'm going to go ahead and find out my critical numbers. David, you know what the critical numbers are? -1 and 2. Good. So now I'm going to go ahead and put it in the sign chart here. This is -1 and 2. Those do that. And then what I get is a plus 1, a minus 2. I need a number that's smaller than -1, so -5,000. That's negative. That's negative. Between -1 and 2 is probably 0, so 0 will give me positive, 0 will give me negative, and then 1,000 will be positive, positive. My final intervals are positive, negative, positive, again, like the last one. Most quadratics follow that pattern. Since I'm looking for intervals that are greater than or equal to 0, which intervals am I looking for? Let's see. Alyssa, which ones am I looking for here? Greater than 0, I'm looking for the down to the left, right? So the positive ones. So the way this is written is my positive interval starts at negative infinity and it ends at -1. Now I can never get to infinity, so that's going to be a soft bracket. -1 can have a hard bracket because I am allowed to include it thanks to my greater than or equal to. That symbol that allows me to jump over an interval is union. I include 2 and I go to positive infinity, but since I never get there, I don't include it. Good, David?
Yeah.
All right. Okay, so that was 67. Okay, 68. Who asked for 68? Okay, good question, Leanne. This is actually a very good one. N plus 5 squared is less than or equal to 0. Okay, so Leanne, this is really n plus 5 times n plus 5. Yeah? So, do you know what my critical numbers are in this one? And do I need to repeat it? I don't. It's just -5, right? So I'm going to pump this into the sign chart. But this time I only have 2 intervals, so that's good. I have n plus 5. Now I'm going to go n plus 5 squared. You okay with that, Leanne? Okay. So, Leanne, give me the biggest negative number you can think of. -1 trillion. If I put -1 trillion into here and I square it, you know what kind of number I get? A positive number. Give me a number that's bigger than -5. Give me the biggest positive number you can think of. You mean positive a trillion? Positive a trillion. You know what big positive number squared is? It's positive. So this whole thing is positive, positive. So we're looking for the intervals of where it's less than 0, so we're looking for where it's negative. Where is it negative? Nowhere. So what's the answer? Yes, Yael. Okay, Yael, give me a really small negative number. -6. Okay, let's go -6 plus 5, right? Squared. This is -1, right? What's -1 squared, Yael? 1, right? No, Yael, I can, no matter what I put in here, it's going to be positive because I'm squaring it, right? Okay, so that's why, you know, there's that. What do you mean?
Like instead of less than or equal to.
If it was greater than or equal to, then it would be all real numbers. Yeah. Yeah.
So you got the fact that it's no solution because both of them are positive?
Because both of them are positive, and because I'm looking for where this is less than 0. Okay? Mark. Oh, well, in this case, we're looking for less than or equal to, so just look for the negative intervals. Okay, so 87. Oh, another sign chart problem. Okay, this one here. Factor out an n. It's not? Oops. Okay, well, we'll do this one anyways. N equals 0, n equals 5 over 7. Okay? So here, I'll just do this one really, really quickly. It's 0 and 5 over 7. Okay? This is, I'll just do it quickly. It's going to be negative, or positive, negative, positive. All right? So we're looking for this, so it's going to be negative infinity, comma, 0, union, 5 over 7, oops, comma, positive infinity. All right? So let's try the real 87. 87 is 3m squared plus 10m minus 8 is greater than or equal to 0. Okay, so we got to factor this thing. It's 3m and m. Let's see, if we go 4 and 2, yes, because that'll give me 6, that'll give me 4, that gives me 10. Good. So, actually, wait a second. No, that's not right, because I need one of those. So it's actually going to be 4 this way and 2 this way, because it needs to create a -8. So it'll be a positive here and a negative here. So m equals 2/3 and -4. Those are my critical numbers in this function, so it's going to be -4 2/3. That's going to be 3m minus 2, m plus 4. So I need a number smaller than -4, so that's going to give me negative, negative. In between these is 0, so that's going to give me, looks like negative, positive. Beyond it's going to be positive, positive, so it's going to be positive, negative, positive. I'm looking for stuff that's greater than, so it's going to be my positive intervals. So my final interval notation is going to be negative infinity, comma, -4. Union 2/3, comma, positive infinity. Have I lost someone? Have I lost someone? The what? M? That's the variable that I'm using. Whoopsie. Okay, 94 is the last one. Oh, another sign chart problem. Excellent. Oops, and... Oh, 94? We'll do 93. 93 is better. Okay. A plus 2, A minus 5, oops, 2A minus 7 is greater than or equal to 0. Okay, who asked for this one? Okay, good. So, David, do you know what the critical numbers on all of this are?
-2, 5, and 7 over 2.
Okay, good. Now, here's the real question. Do you know which one's bigger, 5 or 7 over 2? 5 is bigger. Good. 7 over 2 is 3.5. Okay, we're going to partition this down. All right, David? Good?
Yeah.
Okay, so it looks like my functions are a plus 2, a minus 5, 2a minus 7. Okay, so David, I need a number that's smaller than -2. -10. That's going to be negative all the way. In between -2 and positive 3.5 is going to be 0, right? So that's going to give me positive, negative, negative. In between 3.5 and 5, let's try 4. Positive, negative, positive. And then beyond 5, it's going to be all positive. Duh? Okay. My final intervals here are negative, positive, negative, positive. Now, David, remember, I'm looking at the original problem here. I'm looking for where this thing is greater than 0. So which ones am I looking for? The positive ones. So my final intervals in interval notation are going to be between -2 and 3.5, union 5 to positive infinity. Cool? All right. We'll keep going in a little bit. All right, we're on number 116. They're asking you to graph this thing, and it's a hyperbola because one of the square terms is negative. So I'm going to go ahead and divide by -25 because that's what we do in a hyperbola. We set it equal to 1. So I'm going to flop these also. It's going to be y squared minus x squared equals 1. Does everyone understand how I did that? Right? Negative divided by negative is positive, and then positive divided by negative is negative. So this is my equation here. Oops, sorry, that's not it. That's not it. It's y squared over 25 minus x squared over 25 equals 1. Okay, so now I have to figure out a few things. My center, anyone know what the center of this hyperbola is, Skylar?
0, 0.
It is 0, 0. A, B, and C. What is A and what is B? This one should be a piece of cake. Nikita. 5 and 5. Now, C is going to be found using C squared equals A squared plus B squared, right? Because it's always CAB formula opposite, and since we're dealing with a hyperbola, that's minus. We add our A and B terms. This is rad 50. I don't need you to reduce it, but I do need you to kind of guesstimate what rad 50 is. Rad 50 is What? Who can raise their hand and take a guess? What's rad 50? Mark?
7.2.
About 7.1-ish, right? Because, 49 is 7, so 50, one more. Not that 7.2 would be terribly wrong. Okay, so now let's go ahead and graph this thing. So we're at centered 0, 0, so I go out 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And I draw my vertices. And then I draw the box. I draw my asymptotes through the corners of the box. Now, 25 and 25 are matched. What type of hyperbola is this? Because it's either side to side or up and down. Which one is it? Yael! How did you know that, Yael? Because y is in the front and x is negative. Very good. Okay, so now my focal distance is going to be 7.1, so that's 5. 7.1 is going to be about right here and about right here. Now, once we're done graphing the hyperbola, we need to find a couple more things. The vertices. We always center our vertices at 0, 0. Now, it's going to be plus or minus 5. Which one's going to get the plus or minus? The x or the y? Jake? The y. Because it's an up and down. 0 plus or minus 5. And the focal coordinates are going to be anchored at 0, 0 plus or minus root 50. And then the asymptote slope. In the book, or in the answer key, they give you the entire equation of the line. I just need you to find the slope. Who knows what the slope of this line is, of the asymptote slopes? Jake? Kind of. Plus or minus 1, because it's 5 over 5, right? Okay. That's 107, or 116. Let's do 107. Let's move back a little bit. Yes. This one here, negative 19 minus 2y minus 16x equals negative 4x squared minus y squared. Okay, so from here I'm going to go ahead and add 4x squared and y squared to both sides. So what I get is 4x squared minus 16x plus y squared minus 2y equals 19. I added 19 to both sides. All right. So that's what I end up with. Let's go ahead and clean that up a little. Okay, so from here I got to use completing the square. I'm going to go ahead and factor out a 4. Factor out a 4 here. That leaves me with x squared minus 4x plus y squared minus 2y equals 19. I'm going to add the box. I'm going to add the box. The box is here. Inside the box goes a negative 2 and a negative 1, a negative 2 and a negative 1. Who can raise their hand and tell us what is the one thing that needs to carry over with the box? Señorita. Times 4 the first box. Okay, so what I get on the easy side is 4 quantity x minus 2 squared plus y minus 1 quantity squared equals, well, that's 4 times 4, that's 16. 1, so 19 plus 16, 20 plus 16 is 36. So divide by 36, this is obviously an ellipse. So what I have is x minus 2 squared over 36 plus y minus 1 squared over 36. And the first one should not be 36. I made a mistake. That one should be 9. Darn it. And that equals 1. Okay. What is the center of the ellipse? Center of the ellipse. Scholar. 2, 1. Opposite intuition, right? And then A, B, and C. Okay, what's A in this case? Nikita. It is 6. B is 3. Okay? C is found using CAB formula, so it's C squared equals A squared minus b squared, so it should be rad 27. Don't worry about reducing it. I just need an estimate. Should be about 5.2. Okay, let's go ahead and graph this thing. My center is at 2, 1. I'm going to move out. Which way am I going to move 6? Which way am I going to move 6? Up and down or left and right? Which one is it going to be? Nikita? Up and down. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And then to the left and right, 1, 2, 3. 1, 2, 3. So your ellipse should look kind of like that. And then your focal coordinates are going to be up 5 and a little bit, down 5 and a little bit. From here, we need to find the major axis length, the minor axis length, and then the focal coordinates. What's the major axis length? Alan? 12. Minor axis length, Alan? 6. Focal coordinates, we anchor from the center, so 2, 1. Which one of those gets the plus or minus? Which one of those gets the plus or minus? Nikita? Y. So plus or minus root, darn it. Plus or minus root 27 and parentheses. All that information is going to be necessary for full credit on that question. Okay? Cool. All right. Are there any other questions before we close up the video? Any other outstanding questions? All right. Alyssa. 165, sure. Oopsie. Oh, yes, thank you. Thank you for reminding me. Okay, so before I do that, I'm actually going to do 162 first. And we're going to write the equation of this quadratic with these roots. Oops, 5 or 8. Okay, so when we write the equation of a quadratic, we have to put this in a form that can be FOILed. So it's going to be x minus 2, and then x minus 5 over 8. From here, I'm going to multiply the right side by 8 to kill off the denominator. So what I get is 8x minus 5 times x minus 2. From here, I'm just going to go and quickly FOIL this out. This is 8x squared minus 5 minus 16, so minus 21x plus 10 equals 0. Okay, that's how you do these problems in their most basic form. It gets more complicated when you throw radicals in there. So the roots here are 4 plus root 3, 4 minus root 3. And so what we're going to do is we're going to set this up as x minus, parentheses, 4 plus root 3, and then x minus 4 minus root 3. Okay, the temptation might be to distribute the negative and make a trinomial times a trinomial. Please don't do that. You're going to make life very, very difficult for yourself. Just FOIL it normally. This is x squared. This is x times a negative thing, which means it's going to be negative x times the thing. Well, the thing happens to be 4 minus rad 3. Again, another x times a negative thing, that makes it negative x times the thing, and the thing happens to be 4 plus rad 3. Oops. And then it's the thing times the thing. Negative times negative is positive. 4 plus rad 3, 4 minus rad 3. Now, what do you expect to happen to those rad 3s when we're all done with the problem? They should probably cancel each other, right? So let's see if that happens. I'm going to carry this down. X squared minus 4x plus x rad 3 minus 4x minus x rad 3. And then I'm going to multiply some conjugados. 16 minus 3. And that's 13. What do you know? The x rad 3's get out of there. You end up with x squared minus 8x plus 13 equals 0. And you're done.